Hey, welcome back. We're going to pick up with properties of water solutions. So, some properties that are unique about water are the ability to conduct electricity. So, we're going to break our compounds apart into two different groups. We're going to break them into electrolytes and non-electrolytes. Electrolytes are going to be solutions that have ionic substances dissolved in them. So, some examples would be Pedialyte. It says right here, electrolyte solution. You could think Gatorade, Propel. All of those electrolytic drinks are able to conduct electricity. In fact, if I took a battery over here and put the leads into the conducting solution, it would be able to power a battery. So that's how we define electrolyte is can it conduct electricity from one end of a battery to the other to be able to power a light bulb. Now, non-electrolytes are things that have dissolved molecules that are not conductors, and they're usually not ionic. They're usually going to be covalent. So an example would be sugar, sugar, flour, things like that. Any of the alcohols, they're not going to conduct electricity. So if I took a 9-volt battery and put the electric leads into a non-electrolytic solution, the battery is not going to be able to power the light bulb because the electricity isn't being carried from one lead to another. It's essentially stopping. Okay, remember, part of electricity is we had to have a circuit that was completely connected all the way around from the battery all the way to the light bulb. And that having a non-conducting solution ruins that circuit. So ionization of water solutions is really important because we're going to talk about acids and bases, and we just got done talking about electrolytes and non-electrolytes. So ionization is when ions are going to be formed from molecules. So we're going to take things that are neutral, and we're going to be able to form ions, cations and anions. So this occurs as the molecules dissolve in the water, so as we're creating a solution. So taking something and dissolving it in something else, usually water. Now hydronium is going to be the ion that is the water with an extra H+. So if we're looking at the image here, we have water and HCl, which is a strong acid. We're making a solution by mixing them together. And then what's happening is the hydrogen that's on the HCl is going to leave and hop over to the water, and it's going to have one oxygen with 3 hydrogens and an anion of chloride. And so this is H3O plus and chloride. And this molecule here is hydronium. Now water is unique in that this does it all by itself. So water has 2 hydrogens, but at any given moment, one hydrogen is giving up its hydrogen to the other water, forming hydronium and what's called hydroxide, which we're going to see is important when we talk about bases. So this is called autoionization because water can do it all by itself. All it needs is another water molecule around, and so at any given moment, if I was to take a scoop of water, it would be water, water, hydronium, and hydroxide, all of the things existing at one time. Colligative properties are 3 unique things about solutions that are interesting and relevant for everyday life. There is a 4th colligative property that we're not going to talk about in specific. So just know if you did learn about a 4th one, there is still a 4th one. The 3 that we're going to focus on are vapor pressure depression, boiling point elevation, and freezing point depression. And you need to know all 3 words together. You need to know it's vapor pressure depression because this tells you that something's lowering, this tells you something's elevating, and this tells you something's lowering. So that helps you identify what the trend should be. So with vapor pressure depression, this is adding a solute to water decreases the vapor pressure of water, making it harder to evaporate. So essentially what happens is if we have water here and we start adding in solutes, so I'm going to add in sodium and I'm going to add in as chlorides, and I try to evaporate or boil this water, it's going to have a hard time escaping because the sodiums and the chlorides are basically going to act like a really big O line, offensive line, and they're going to block the people from coming through, the people being the water, because they're going to be such a big imposing force. And so that's kind of what a solute does to the water. It doesn't allow it to pass through to be evaporated. Boiling point elevation is kind of the same trend. Adding a solute to water increases the boiling point of water, making it harder to boil. So the water doesn't boil at 100 degrees Celsius anymore. It's going to be elevated based on the amount of salt that you add or what kind of salt you add. So it makes it harder to boil. So think about the fact of why do people add salt to water when you boil pasta? You need to make sure you read in your book because your book has a really nice description about what's going on here. So make sure you go back to your book and you read. The third one is the freezing point depression. This is adding solute to water, decreases the freezing point of water, making it harder to freeze. You have a question in your notes that says, what's a real life example about this? And what I want to encourage you to think about is, pretend that you wake up tomorrow morning. The weatherman says, it's 31 degrees outside and it's raining. What's the first thing you're going to think about the roads? You're probably going to think, well, the roads are going to be iced over. However, there's also another thing that highway maintenance and city maintenance does to the roads to help prevent that from happening. So make sure you take into account that. And if you're not sure, then just email, Google, but reach out and make sure you understand that think question. So this leads us to acids, bases, and salts. So these are three classes of electrolytes. These are things that when dissolved in water will conduct electricity. We have our acids, which you can see here: aspirin, tomato, lemon, vitamin C, red wine vinegar. Bases are Maalox or any type of upset tummy medicine, baking soda, ammonia, Drano. Then you have salts: Epsom salt, kosher salt, ammonium sulfate. This is a fertilizer that people use. So these are just household examples of electrolytes in your everyday life. So let's talk about some properties of acids. Acids tend to be sour if you tasted them. So think about lemons, think about oranges, vinegar, just sour. They change the color of certain materials like litmus paper to red. So if I had orange litmus paper or blue litmus paper, it would turn red in the presence of an acid. If I had red litmus paper, it's going to stay red. So you have to make sure you're using the right litmus paper. Acids will react with active metals like magnesium and zinc to release hydrogen gas, which is flammable. It's a pretty cool reaction, but because of the hydrogen and the flammability of hydrogen, it's kind of dangerous. But another thing about acids is that they neutralize bases. When that happens, it forms water and salt, and we'll come back to this in just a few slides. These are some examples of some common acids. You have acetic acid, which is vinegar; boric acid, which is in your eye drops; carbonic, which is in your sodas; formic acid, which is what hurts when you get stung or affected by a poisonous plant. And then you can go through and you can see lots of examples of other ones that you might encounter in your everyday life. So bases are also called alkaline substances, just like alkaline batteries, just like alkaline metals, alkaline earth metals. So bases, alkaline, very similar type of use as far as interchangeable words. So bases, on the other hand, tend to be bitter. Now, we don't tend to taste a lot of bases. The only one I could really think of that you would taste would be maybe milk of magnesia, which is used in antacids and laxatives. Everything else with bases tends to be a cleaner or construction, so not something you would be tasting. Now, if acids turn something red, bases are going to turn it the opposite. So bases will turn orange litmus paper blue, red litmus paper blue, but if you're using blue litmus paper, it's going to stay blue. Bases tend to be slippery on the skin. The caustic action converts your tissue into soluble materials. So that's why whenever you use oven cleaners, drain cleaners, Ammonia, you really should use gloves because it will dissolve away the epidermis layer on your skin and basically just dissolve it away. And it's really slippery, so you'll know if you have it on you because it's going to feel like slick material. Now, bases, if acids can neutralize bases, then bases neutralize acids, which form water and salts. So acid-base properties. We've now defined the different properties of acids, bases. We're going to define one other thing. Acids are going to be proton, which is a hydrogen with a plus charge, proton donors when dissolved in water. So when I take something like HCl or HNO3, which were examples on the previous slides, they're going to donate that hydrogen in water. Okay, they're going to donate the hydrogen to the water. On the other hand, a base is going to be a proton acceptor when dissolved in water. So this is going to be the water accepting the acid. In this case, the ammonia is going to be a base. We've already said that, so we know it's going to accept a proton from the water. So what you can see here is we're always going to have an acid and a base together. When we have an acid and a base together, we're going to call that reaction neutralization, which is the result of mixing acids and bases. And remember, what's always going to form, the products will always be water and a salt. Okay, it's an important, that's what makes them neutral. Water is neutral, salts are neutral. So acid-base strength, we have 4 different categories. We're going to have strong acids, strong bases, weak acids, weak bases. The one thing you need to know about how they get defined is acids, we said, are proton donors. Bases are going to be proton acceptors. And the only difference between strong and weak is how much they ionize. So remember when we said they form ions in solution? Well, strong acids are going to make 100% ions in solution. So are the bases. The only thing is that if it's weak, it's going to be partially ionized. So less than 100%. Okay. You don't need to know the strong acids and the strong bases, but you just need to know how we define them, which is based on how much they ionize in solution. The pH scale is our last topic. It's the scale that we use to express the strength of an acid or a base, and it has an entire range of values. The ones we're probably most familiar with are the pH of 0 to 14, but how we measure that pH is based on hydronium concentration. When we have a pH of 0 through, this should be like 6.99, that's what we're going to define as an acid. When the pH is 7.01 to 14, we're going to define that as a base. Only when the pH is 7.00 are we going to say it's neutral. It must equal 7 exactly. Everything else is acidic or basic. Now, it's a measure of the amount of hydronium in the solution. The acids are going to have more hydronium. Bases are going to have less hydronium. And we can see that because these exponents are really, well, they're really big, but they're negative, which means it's actually a really small number. So this would be 0.000000001. This number up here is 0.1. So there's way more hydronium here than here. Okay? So the more acidic, the more hydronium, the more basic, the less hydronium. What's happening here is because this has less hydronium, it's actually going to have what's called more hydroxide, which if you remember back to the ionization that we talked of water, the hydronium component tends to be acidic, the hydroxide component tends to be basic. So when it's like a seesaw. When one goes up, the other goes down. When we're at a pH of 7, The amount of hydronium equals the amount of hydroxide. So they cancel each other out, which leaves us with a neutral pH. This is going to end chapter 10. Make sure you follow up with the activity and turn in your notes when you are done, and ask any questions if you have them.